Welcome to today's deep dive. So today we are getting into something that I think a lot of people misunderstand. We're exploring the really high-stakes world of exporting swarm intelligence.
Right, specifically software classifications for drone orchestration.
Exactly. So for the autonomous software founders out there, tactical AI engineers, or even those of you who are small military prime contractors, the mission today is to decode these incredibly complex export compliance regulations. We're talking ITAR and ITAR and how they govern your actual code.
Yeah, because we really need to clarify when your standard commercial software suddenly becomes a controlled defense asset. And how to protect your IP from some pretty severe criminal violations.
Yeah, and that brings us to the hook here, right?
Yeah.
Because many tech founders are operating under this really dangerous misconception.
Oh, absolutely. The biggest trap.
They believe that, well, as long as their multi-agent pathfinding software is running on standard commercial off-the-shelf chips, like, basic civilian hardware, instead of some military-hardened processor, that it just remains a generic dual-use commercial application.
Which is a massive compliance error. I mean, it's huge.
Right. The physical hardware doesn't protect you at all. The moment your swarm orchestration software incorporates tactical features, you are no longer just an app developer. You are compiling a strictly controlled weapon system.
Exactly. You're building a munition. And to understand how a commercial product accidentally becomes a weapon system, we really first have to draw the exact jurisdictional boundary between the two primary regulatory frameworks here, which are the ER and the ITAR.
Right, the Export Administration Regulations versus the International Traffic and Arms Regulations. So let's look at the, I guess, safer side of the fence first.
Sure. So standard commercial multi-drone orchestration software. Think about the systems used for those big entertainment light shows you see at theme parks, or synchronized agricultural mapping over farmland.
Okay, yeah, like the drone displays at the Olympics.
Right, exactly. That kind of software falls under the ER. It's typically governed by an ECCN, an export control classification number, like 9D01 or 9D002.
And that covers software specially designed for the development or production of dual-use aircraft, right?
Yeah, exactly. It's regulated, obviously, because it involves aviation, but it has clear commercial applications. However, the software crosses a very rigid legal line into the U.S. Munitions List, the USML, under ITAR Section 120.6, the very second it enables autonomous collaborative behavior specifically for tactical execution.
Okay, so if you build code that tells 100 drones to fly in the shape of a corporate logo for a theme park, you're under the EAR.
Yep, you're fine there.
But if you tweak that exact same pathfinding math so those drones can, autonomously flank a moving target, you've suddenly crossed into ITAR territory.
You have, even if the physical drone is a commercial item, like logistics robotics that are just classified as ER99. If the software dictates tactical swarming, the software itself is under ITAR jurisdiction.
But wait, going back to the math for a second, how does the law actually tell the difference when the underlying algorithms look nearly identical? I mean, vector math to avoid a tree is the same as vector math to avoid a building, right?
That's a really good question, and it's because regulatory agencies, they aren't just evaluating the raw mathematical equations, they're looking for specific functional behaviors.
Oh, okay.
We call these diagnostic triggers. And when they see these behaviors, it instantly reclassifies your entire software repository as a defense article.
Which is terrifying for a founder.
It is, and there are three major diagnostic triggers that founders really need to watch for.
Okay, let's walk through those. What's trigger number one?
The first one is dynamic reallocation. So, does the software allow the drones to dynamically reallocate target assets without human intervention?
Okay, I assume this means if you have a swarm of 10 drones scanning a grid and one drone loses its battery and drops out of the sky, the swarm just autonomously recalculates its formation to cover the missing drone's sector, all without a human pilot clicking a button.
Exactly. You've removed the human from the loop. Now, in a commercial search and rescue setting, that's incredibly useful. But tactically, if the swarm can dynamically reassign which drone is engaging an adversarial target after taking casualties, the software has become a tactical commander.
Wow. Okay, so that's trigger one. What's the second one?
Trigger two is networked sensor sharing. This asks, does the software optimize sensor data to track, jam, or engage a target across an adversarial network?
So we aren't just talking about, streaming 5 different video feeds back to a central laptop for a human to look at.
No, not at all. We're talking about the swarm acting as a single distributed intelligence.
Right. So the drones are analyzing the feed in the air, recognizing a threat, and then the swarm commands a specific drone to adjust its frequency to jam the enemy's radar.
Exactly. It's utilizing its decentralized nature to defeat an enemy system collaboratively. And then trigger number 3 is probably the most overt one. It's tactical integration.
Meaning what, exactly?
It looks at whether the system was built to integrate directly with military data links. Like, for example, Link 16.
Oh, okay. So if trigger 1 is human removal, and trigger 2 is sensor sharing, trigger 3 is how these drones actually talk to existing military infrastructure. Link 16 is that standardized radio network the military uses to share tactical data, right?
Right. Between ships, aircraft, troops, all in real time. If your system is built to plug into that, well, you can't really argue it was designed for agricultural mapping.
Yeah, that makes sense.
And if the answer to any of those 3 is yes, your software repository is categorized as a defense article, usually under USML category ECNEA for military electronics, category 8 for aircraft, or category 14 for payloads.
And exporting this controlled code without a license from the DDTC, the Directorate of Defense Trade Controls, is a federal violation. But exporting in today's world doesn't mean shipping a hard drive across a border, right?
Oh, definitely not.
Because the sources talk a lot about deemed exports and modern collaboration traps.
Yeah, the modern data flows are where companies really get caught. You don't have to physically ship anything.
Wait, so let me get this straight. You're saying just dropping a file into a shared Slack channel with a foreign contractor on your team can trigger a violation?
Yes, absolutely. Or giving an access token to a multi-tenant cloud environment where a foreign national has administrative access, or even pasting a snippet of that ITAR-controlled code into an unmanaged Gen AI prompt to fix a bug.
Because the AI platform might route that data through offshore servers.
Exactly. You just transmitted a restricted weapons schematic to an unauthorized foreign network.
Wow. One careless copy-paste into an LLM and you're looking at what? Massive fines?
Try civil fines up to $500,000 per violation.
Per violation.
Per violation, plus potential criminal penalties. The operational risk is just staggering.
That is, I mean, that's wild, but it's not just the transfer of existing code that founders need to worry about, right? Because the sources also detail this other snare, which is the defense service trap.
Yeah, this is where consulting or custom engineering gets really dangerous. Under ITAR section 120.32, providing a defense service includes furnishing technical data or assistance to foreign persons.
Assistance in doing what?
In designing, developing, engineering, or modifying defense articles. Let's look at a scenario that traps a lot of well-meaning teams.
Okay.
Imagine a foreign ally buys unclassified, dual-use commercial logistics drones, ER-99 items, perfectly legal.
Right. And let's say they want to use them for a strictly humanitarian mission, like delivering medical supplies across a contested zone where adversarial forces are jamming GPS signals.
Right, great PR, totally life-saving mission. But they hire your firm to write a custom software layer, enabling those drones to operate as an autonomous swarm, specifically to defeat that jamming.
Ah. It sounds like selling someone a civilian off-road vehicle is fine, but the moment you agree to teach them how to armor it to survive a war zone, you've suddenly transformed into a regulated arms dealer. The service is the weapon.
That is a perfect analogy, yes.
Yeah.
Even though the physical platform is commercial and the cargo is strictly humanitarian, engineering custom swarm control logic to defeat adversarial jamming creates a tactical countermeasure asset.
Wow.
So modifying those algorithms alongside international teams without an active technical assistance agreement, a TAA that is a criminal violation.
A TAA is what authorizes the performance of a defense service, right?
Exactly. You have to have it before you start collaborating.
So if the trap of accidental defense services is that easy to fall into, how do autonomous software founders protect their commercial IP from being entirely swallowed by ITAR?
Well, they have to use a specific legal shield built into the EA. It's under Part 772, the definition of specially designed.
Okay, how does that work?
It essentially functions as a catch-and-release mechanism. Even if a piece of software seems caught by a military control, it can be released back to dual-use EAR status if it meets specific criteria.
Like what kind of criteria?
There are 2 main releases. The first is the B4 release. This applies to simultaneous development. So developing the software with the documented knowledge that it would be used for both defense and civil applications from day one.
Oh, so you plan for it to be dual use right out of the gate.
Right. And the second is the B5 release, which means it was developed as a general purpose commodity or software with no specific intent for a particular military platform.
Okay, but does this mean that software founders essentially need to act like compliance lawyers from day one? Like, do they have to document every single whiteboard brainstorming session just in case the military wants to buy their tech 3 years down the line?
Honestly, yes. To use this shield, you must maintain strict contemporaneous records.
What kind of records are we talking about?
Everything. Initial software requirement documents, commercial testing protocols, concept designs, marketing portfolios. You have to show that the identical repository engine is sold to non-defense buyers.
Without any specialized tactical variations.
Exactly.
Yeah.
Because failing to establish this commercial origin trail before entering into defense contract discussions makes surviving an audit nearly indefensible. You can't retroactively claim it was a general purpose tool if you have no proof.
Okay, so knowing you need to document your code is one thing, but operationalizing these massive regulatory frameworks in a fast-moving, agile engineering team that requires a concrete plan.
It does. You need a very strict compliance checklist for autonomous orchestration.
Right, let's walk through that checklist for the listeners who are actually running these teams. Step 1, according to the sources, is repository isolation.
Yes, you must segment your core swarming repositories. You have to keep dual-use commercial libraries completely separate from code bases developed specifically for defense contracts.
So you can't just have one giant monolithic code base where everything mingles.
No, absolutely not. If they mingle, the ITAR classification infects the commercial IP.
Okay, step 2 on the checklist is audit engineering requests.
Right, so this means you don't just look at the code, you look at what the customers are asking for. You have to review feature requests for hidden tactical triggers.
Like the diagnostic triggers we talked about earlier.
Exactly. If a customer request includes phrases like autonomous asset handoff, or anti-jamming resiliency, or kinetic payload synchronization, those are massive red flags.
You have to catch those before a developer even writes a line of code.
Precisely. And that leads to step 3. Implement a software TCP, a technology control plan.
Okay. What does a TCP actually do in practice? Is it just a policy document people sign?
No, it needs to be programmatic. You enforce a strict TCP that programmatically restricts foreign national engineers from reviewing swarm optimization logs or sensitive repositories.
So it's hard-coded into the access control.
Yes, it sets out the organization's physical and IT controls, vetting, non-disclosure training, and ensuring employees actually know they cannot re-export or transfer controlled technology.
Man, this requires a massive mindset shift. You aren't just building a software firewall to keep hackers out. You have to build a regulatory firewall directly into your company's HR processes, your project management software, and really your whole team culture.
It really does. It dictates how you hire, how you collaborate, everything.
Well, to wrap this up for you listening, building cutting-edge swarm orchestration software is clearly only half the battle. Structuring your business, your repositories, and your engineering services to navigate these invisible lines between the ear and the ITAR is what ensures your company survives its own success.
Absolutely.
But before we go, I want to leave you with a final forward-looking question to mull over, something that wasn't explicitly covered in today's compliance frameworks, but is right on the horizon.
Oh, this is the generative AI scenario.
Yeah. As AI and autonomous systems become increasingly generative, capable of writing and optimizing their own code on the fly, what happens when a legally compliant commercial EAR-99 drone swarm teaches itself a tactical ITAR-controlled evasive maneuver in the field?
Right. Just to survive an environmental hazard or something.
Exactly. When the software spontaneously rewrites its own jurisdictional boundary without a human ever touching a keyboard, who is responsible for the export violation?
It's a huge gray area. The system autonomously chooses to become a munition.
Right. It's something to think about the next time you're compiling that quote-unquote harmless math. Thanks for joining us on this deep dive, and we'll see you next time.